Good morning, everybody. Again, welcome to this webinar about secure software development lifecycle. My name is Jalmar van Bochelen, and I am the moderator today. I will be doing this webinar together with my respected colleague, Tim Hemel, who is very experienced in the field of implementing secure software development and training. For those who do not know Secura, I try to explain in a few words using the beautiful Secura House of Security. Secura was founded almost 20 years ago and has gained a lot of experience. Over the years, we have developed a more holistic approach in the field of IT security and offer multiple services with different expertise. Our roots lay in security testing, and this is still something we do very frequent. Because it is not enough to only check the final product, we have set up a professional audit team. We help organizations to set up security frameworks, implement ISO norms, or audit IT systems. We also set up an extensive security awareness program and train teams and people to be more secure aware. Over the years, we developed different tools for our own use, and some of these tools we made suitable for use by our customers. For those who know us, the secure file exchange is a nice example. All the effort we put into security should result in something that is tested using existing and new standards. Therefore, we close the Secura house with the assurance and certification service. If you'd like to know more about Secura or our services, please check our website or contact me or one of my colleagues. It is time to move on and start with the interesting part of the webinar. Explain all you want to know about secure software development lifecycle. At the end of the webinar, do not leave immediately. There is time to ask questions and Tim will be happy to answer them. And Tim, would you take over from here?
Yes, thank you, Jalmar. So let's talk about shifting left. What is it and why do we need it? We will look at some activities that are part of the secure software development lifecycle. And finally, we will see how to get started. So let's say we are working on a typical software project. We have our stories that flow from our backlog to a design phase, a coding phase, and a testing phase. And just before the release, we have planned a security test. Now, as we work on our stories, everything flows nicely, it goes according to plan, but we cannot do the security tests until everything is built. There needs to be something to test before we can do the complete test. So we need to wait there. But then when the test is finally happening, we always get a bit nervous because things may work out fine and we can release, but we may also get some security findings, and they usually lead to unplanned work. And in this case, we have three options. We can work extra time to do all this unplanned work. We can delay the release, or we can release vulnerable software. And all of these are bad. So our solution is to do security earlier. This is called shifting left. We need to move from here, this situation, to here. And as you can see, security activities can fit into many more phases than just verification and operations. And we can also do a lot in the design and implementation phases. We call this security by design, SSD, or secure software development, or shifting left. And of course, it's called shifting left because most of these activities are on the left of the verifications and operations phase. Also note that the flow goes to the right. So if we want to shift left, we have to go against the stream. And this is always a bit difficult. The OWASP-SAM project documents certain security practices in each of these development phases, and they organize them in various levels of maturity. And we're going to use their structure here in this presentation. So let's see what these security activities look like. In the design phase, I would like to talk about security requirements and security architecture. So security requirements tell us what security means for us. This could be for our organization, our systems, or our application. And having security requirements really helps us to focus on the right security activities and spend our resources wisely. And that's why they are very important. Before we can, however, make such requirements, we need a good definition of security. And I took this one from the dictionary. Security is being protected against threats. And you will notice two important things here. In order to answer the question whether you are secure, you will need to know your threats, and you will need to know how to protect against them. But this also means that 100% security is difficult because we can never know all the threats that we have. And also, the environment has a big influence. Or there may be conflicts between security and usability, security and performance, or security and privacy. And of course, sometimes security can be simply too expensive. So we should not strive for 100% security. We should strive for a system that is secure enough. Now, with this definition, we can try to derive security requirements. And usually, we already have functional requirements that describe what our system should do. Security requirements usually describe what the system should not do, which is in this case, what threats do we not want to happen? We can derive these security requirements from our functional requirements. And for that, we like to use a systematic approach using STRIDE. Now, STRIDE is an acronym invented by Microsoft that describes 6 types of attacks. Spoofing, which is pretending to be someone else. Tampering is about modifying data. Repudiation means that you are able to deny a certain claim. Information disclosure is seeing something that you should not see. Denial of service is making a system unavailable. And elevation of privilege is doing something that you're not allowed to do. And with each attack type, there is an associated security property. So for example, to protect against spoofing, we want to have the property of authentication. And against tampering, we want to have integrity. Against repudiation, we want non-repudiation, and so on. We can think which of these properties we want to have in our system, or equivalently, which threats we don't want to have. And to do that, we ask questions about every functional requirement that we have. Take, for example, the following user story. As a participant, I want to listen to a webinar. We can ask questions about all these properties. For example, do I need to authenticate for this? Do I need to log in, for example? Or how confidential is this webinar? Can everybody see it, or just a selected group of people? How important is the availability here? And can I listen to all the webinars or just this one? And asking these questions makes the security requirements explicit. It's a very simple technique, but you increase the likelihood that the requirement will be implemented and tested. And besides, some of these requirements are really easy to translate into security tests, but more about that later. So when we know what our system should do, when we have defined all the functional requirements, we can start the design phase. We can choose the technologies to build the system. And every technology you choose comes with threats for free. If you don't know these threats, you will not protect against them probably. So it's very important to know what these threats are. With a process called threat modeling, we can find such threats. And in threat modeling, we combine the knowledge of a security expert with the developer's knowledge of the system. And as you get some sort of mind melt as it is. And after we've found many threats for a system, we can think of mitigations. And mitigations are ways to lower the risk of these threats. So let's look at an example. In threat modeling, we often start with an architecture diagram. And here you can see a data flow diagram that shows how data travels throughout the system. Once you have the diagram, you can start finding threats, and not only which threats, but also where they occur. In other words, we map what is called the attack surface. Now, to find threats, you can use strides, or you can use a method called attack trees or a threat library. An attack tree is a diagram that shows all the possible attack paths that an attacker can take in order to break into the system. Usually, they are highly customized for your particular situation. A threat library is a collection of threats that are specific to a certain technology. For example, if you use a web application, there's a collection of threats that you have to take into account. But if you work on a mobile application, there may be completely different threats. And for web applications, we like to use the OWASP Application Security Verification Standard, or ASVS, as a good threat library. Now, threat modeling is a topic by itself. And if you would like to know more, I can point you to our threat modeling workshop. So moving on to the next phase, implementation. Now that we have our technologies decided, we can start building. And here I would like to highlight two activities that belong to secure building. The first one is secure coding. Now, code is an essential part of the system, and therefore we need to code the right things, and we need to code them right. A secure coding standard gives you language-specific security guidelines. It tells you which programming constructs you should use and which ones you should avoid. How do you get such a secure coding standard? Well, you can find them in books. You can find lots of them online, and especially the OWASP cheat sheets are really useful and available online for free. But not all of the code that we write is written by ourselves. Much of it is written by other people, third-party software. And the disadvantage of third-party software is that we don't know how secure that is. We also don't have the time to verify it. Otherwise, we could have written the software ourselves. So the best we can do is to check the software for known vulnerabilities. And we call this a software component analysis. Also, nowadays, you can find many free and commercial tools that try to do this. When our code is done, we can verify it. And for security, we need to verify that our mitigations are correct. And we need to verify that all the security requirements are satisfied. And I like to mention two verification strategies: requirements-driven testing and regular security testing. Now, in requirements-driven testing, we base our tests on the security requirements, but not all requirements are that easy to test. Take, for example, the requirement on the left. Without a valid token, the page should return code 403. This is easy to test. You know when you've done the test, so you can guarantee a certain completeness there. It is also clear what to test, and the code that the test affects is relatively small. But the requirement on the right, however, account information must not be visible to others, is very vague, and we cannot guarantee completeness there. And if we want to test it, we may need to test the whole application, so the test affects all the code. Now, the latter we call anti-requirements, and the former we call positive requirements. And as you can imagine, positive requirements are very good candidates for requirement-driven testing, while anti-requirements are not. How does such a requirements-driven test look like? It's basically very similar to a unit test or acceptance test or any functional test that you normally do. But those empty requirements are still a pain in the neck. Oops. Therefore, sorry. Here we are. Therefore, we still need regular security testing. And we can do this manually, but nowadays we prefer to run tools that do it for us. And within these tools, we have so-called static application security testing tools, or SAST tools. And these look at your source code. Dynamic testing tools look at the running application. There's also interactive tools that combine the best of both worlds, and you try to find potential vulnerable spots in your code via static testing, and then you use dynamic testing to explore them further and confirm these vulnerabilities. And while tools can help, they're not perfect, because first of all, tools don't find all the problems, but more often they find problems that are not really there, the so-called false positives. And while running a tool may be fast, reviewing the output can take a lot of time. And I've heard of companies that bought really expensive tools, but the developers don't run them because there are too many false alarms. So think very well before you invest in such a tool. And when the code is tested, it can finally go live. And here in the operations phase, I would like to pick one item there, incident management. And you may think, well, this is very little to do with software development, but I'll show you how it can be useful. If you get started with this process and you don't really know what threats to tackle first, you can see if you can learn from past incidents. And a very good starting point here are whatever logs that you can find. Look at them, analyze them for potential attacks, and then see which of these are relevant for your system. And this helps you to prioritize to tackle attacks that actually happen first. Now, all these practices are really nice, but we need to fit them into our way of working, so-called governance. And OSM offers some advice on governance, and I would like to discuss metrics and compliance and education and guidance here. And we all know the pressure that software developers experience. And under pressure, it is really easy to cut corners and to skip security practices. We can say, for example, oh, we will deal with this later. And creating such security debt is not necessarily a bad thing, as long as you keep track of it and resolve it later. It's a bit like brushing your teeth. Skipping it once may be fine, but don't skip it too often and make sure you catch up with your dental health. So to do this, we can measure our security efforts and the results. And based on that, we can establish rules that we agree to follow. For example, we can agree to tackle at least 5 security points per sprint. And if we don't, we have something to explain. Similarly, we can agree on executing certain security practices and make them part of our definition of done. But of course, someone needs to run this process. And a security champion is somebody who can do this. Security champion is someone who's embedded in the team, or at least working very closely with the team. And this person has security expertise, but also tries to motivate people by creating a security culture. The champion coordinates between the different departments and the different teams, and therefore it is important that the security champion gets support on all levels in the organization. Also, the security practices cannot really happen if people don't know how to do them. So we need to train our teams. They need to get security knowledge. So the teams need to have at least some knowledge about secure software activities, a bit like the activities we are describing in this webinar and that are described in OSM. Also, knowledge of secure coding is very important. For those who are involved in architecture and system design, threat modeling can be really useful. And if you do your own testing or you have a team of security testers, then security testing is really important. And in my experience, a single training has very little effect. You need to keep training your teams to keep the knowledge alive. And instead of theory, I would prefer hands-on training because it works much better. I know an example of one team that followed a secure programming training twice, but only after a practice session that we organized, they finally understood what was going on because they could actually experience it themselves. And the other advantage of hands-on training is that you can take the time to find out how things work in your own environment, which really helps. It helps to make the connection between your work and security. So now that we have seen some of these activities, let's see how we can put these into practice. For example, how do we get started? Well, the first step is to get support in your organization. Without support, it is difficult to get started because security is really a team effort. Everybody needs to be involved. And once you have support, you should try to get security champions to get things running. And the champions should work on incentives to motivate everybody and to involve everybody in this whole security story and to keep security going as a process. So let's look at each of these. So to get support in your organization, you want to have support on all levels. You want to have it from the software builders, the product owners, whoever is involved. And that can be difficult. And perhaps the most challenging is to get support from higher management. And for that, you may need to make a business case for the secure software development investment. Does it pay off to invest in security? That can be really tricky, but here are some things that you can look at. For example, you can look at the awareness of your security risks. If being in control is really important in your organization, then security awareness and being in control of your secure development process may be something that is really valuable. So you can try and find metrics there, see if you can get more in control. Another thing you can look at is what you are spending on incidents. So keep track of the resources that you spend on incidents and see if the secure software development investment can actually lower them. You can also see how vulnerable you are or how vulnerable you remain after detecting a vulnerability. And if you can reduce that by simply not making those vulnerabilities and therefore reduce the vulnerability, this can be important because if security is really an important thing, you can actually show that the investment will make you less vulnerable. Or you can see what the effect is of all this unplanned work of security findings. And maybe you can show that your whole development velocity actually increases by investing in security by design. And of course, there's a big motivating factor, which is the risk of being fined, for example, by not complying to data protection laws, such as the GDPR. Once you have support, you can find security champions, and these are incredibly difficult to find. So the best source are your own developers. And when I give security trainings, there are always a few persons that are more than just interested in what I have to tell them. And these are very good candidates for security champions. They already know the organization and the way of working, so all they need is a little bit of extra security knowledge. But that is not enough. Security champions also need to have enough authority to get things done. If they don't have that, they become bitter and frustrated, and they may give up really soon. And that's exactly what we don't want to happen. Instead, our security champions need to motivate teams. And one way to motivate a team is to get feedback. If you can get feedback on how well you are doing the security practices, this can be a big motivator. So start measuring how well you are doing these practices. You could look at things like the number of security stories completed versus the number of open issues, the time it takes to fix them, etc. And then see if you can improve those over time. What is very important for the security champions is to work with the teams and not against them. And I've heard stories where the internal security team had too much work, but they still felt offended when the developers wanted to do their own security tests. And of course, that doesn't help. You need a security culture where everybody is working towards the same goal, and you need to accept sometimes that security is not always the most important. So you can also make this whole process fun by creating team competitions or hackathons where you can try to hack a system or even fix a vulnerable system. Now, once you have started, you need to keep growing. And getting a really secure development process takes some time. Therefore, my advice is to start small and grow steadily. You can start by measuring the state of your secure development lifecycle. And then based on that, you can plan improvements. Then after some time and some improvements, you can measure again and plan new improvements. And this goes on and on and on. And the OWASP-SAML standard can really help here. Because next to giving advice on how to do things, it also provides a nice scoring tool that you can use to calculate your maturity level in different areas. And you can fill in a nice spreadsheet, and it creates these nice tables and spider diagrams, etc. That's really good to keep management happy, but it also gives you a good overview of how mature you are. And then you can use this to see which improvements could be useful for that, and then plan those improvements in those areas. So to summarize, if you want to get started with a secure development process, you need to get support first. If you have support already, try to find or train security champions. If you have those as well, start measuring your secure development lifecycle and see what improvements would be good for you. And that brings us to the end, and I'm happy to answer any questions.
Thank you, Tim. That was a very clear explanation, and even I learned a few new things today. We already have some questions, so let's start from the top and see if we can answer them right away. Perhaps if it isn't possible, we will try to answer the questions later on and post them online somewhere with this webinar. And the first question we have is applying a customized security defense for each application necessary post the security practices are done? Is that something you can answer, Tim?
So let me try to see if I understood the question. Is it needed to customize security defenses per application?
Yes.
Or yeah. Well, every application is different, so that would say that would make the answer a yes. On the other hand, lots of applications use specific design patterns and specific technologies, and the defenses against the threats that result from those are pretty well known. And so, yeah, we have custom defenses, but we also have a lot of standard defenses. And as you start this process, you will discover which of the defenses can grow into what I call security design patterns. So in the beginning, it all looks new, but as you mature and you get more applications and you will see more standard solutions to certain threats, your whole threat analysis will actually grow more and more into applying security design patterns. And once you have that maturity, your security analysis will also go faster. So as you grow, you will do more security and you will do it faster also.
Okay, I think that clears it a bit. We have a second question, and that is if it is useful that the Scrum Master will perform the role of security champion. Is that so? Could he help being security champion?
Yeah, the Scrum Master. They could, in a certain way. What is important for the security champion is that they have access to the knowledge. They don't need to know everything themselves, as long as they can find security knowledge there. So that is one thing, knowledge. The other one is the security responsibility and to get things going. And a Scrum Master is traditionally somebody who facilitates things. So in that respect, they would be a good candidate for a security champion. You could also split the role, perhaps, into one person that takes care of all the responsibilities and then another person that has all the knowledge. So there doesn't have to be one person for this role. You could even, within your team, rotate the role of security champion. So this sprint, John, and the next sprint, it will be Mary, etc. So you can be a little bit creative there, as long as you make sure that the knowledge and the responsibilities that come with the security process are, that somebody takes care of those.
Okay, that clears it, I think. Let's go to the next one, and that is a long one. Do we need to have customized third-party tools for our security testing? If so, for example, for a particular application, we started our code analysis with check marks, and the next time we are doing it in an open source. Is that really helpful in change of tools? So do you need to have a customized third-party tool?
That is a difficult one. It really depends on the problems that you find, and I cannot answer this question right away. I also cannot say which tool you should choose for which situation. You should really try and evaluate. That's one thing. Now, most of these tools, like for example checkmarks, they allow you to customize the rules, and that is something you should do over time. But in order to customize things correctly, you need to know what problems you can expect in your code. Otherwise, your tool may not find those problems, or you will get too many false positives, etc. So you really need to tune those tools for your situation, and then it can help you to grow. But remember, tools can only find up to a certain amount of problems. They cannot find all the problems. So it is also good to have a combination of tools. And some of these tools that are available, some of them are open source, are really tuned towards finding very specific issues. And so you could use a combination of those tools. And I would say the more tools, the better, but beware, you need to process all these findings, and that can take some time. So what you could do is, I've heard this advice before, if you run those tools regularly by developers, they can run it with a very limited rule set, so they will not get a lot of findings. And then once every few sprints, you run the tool with all the rules enabled and see if you have missed some things. And that is a way to find a balance between the false positives and the things that the tool didn't find or didn't report. So I don't know if that answers the question, but
perhaps I think it could help the questioner a bit. And actually, we have another one from him. And that says, if the current security practices are given a huge impact post using the new security practices in the sense, do we need to take care for all the applications that we are developing, else we can have one best security practice for all of our application? So the question here is, it's a long question. Do we need to care for all applications? Are we using the same security practice? Isn't that easier to use one security practice than developing all separate security practices for all other applications? I think that's the real question.
So is this about having one security practice for all the teams, or to customize your practices per team?
Yes, I think so. Yeah.
Also, it really depends. Certain practices can be useful for all teams. Other practices may not be that useful. And this depends on the risk exposure of your application. If your application is really security sensitive, you may want to invest more in things like threat modeling, etc., and more on the preventive side than other applications that you would only use internally. We always try to do security in our best way, but we are, of course, limited by our budgets, and we need to spend our resources wisely. And yeah, and the risk exposure of the application is really guiding in this. So you need to choose your resources wisely. And I think a few basic practices, you can do that for all teams. But when it comes to really highly sensitive applications, I think customization is in order.
Yes, that sounds really good. We also have a question about training, and why is training for my people on secure coding not enough to include security in my software development, is one of the questions.
Why is secure coding not enough? Or
Yeah.
Can you repeat it? I'm trying to break down the question.
Yeah, why is training my people on secure coding not enough to include security in my software development? And I think they're trying to ask if you just train people, they should know what to do. And if you have trained people, skilled people, they should write secure coding. Why isn't it that enough?
I see what you mean. Well, many of the security issues result from different phases than the coding phase. And this was shown by Microsoft when they worked on Windows Vista. Microsoft sent out this famous security memo by Bill Gates saying we need to do something about our security now. And for the Windows Vista project, they basically hired every hacker they could find to help them secure Windows Vista. And they made a lot of progress there. And one of the findings that they discovered was that only 50% of the vulnerabilities in programs were code related. The rest was related to secure design and security requirements, etc. So knowledge in those areas is also useful. It's not just code, it's also design and requirements.
Okay, but does that actually need people in your team who have a different mindset than developers? Do you need a hacker in your team?
That's a good question. I always say it is much easier to teach a programmer how to hack than to teach a hacker how to program. And that is based on my experience, because there are many hackers out there that don't really know how to program. And programming knowledge is something, yeah, that takes time to acquire. Hacking knowledge and security knowledge, on the other hand, is much easier, at least the basic hacking knowledge. So do we need hackers? It helps for your awareness to know what can go wrong and to see some actual hacks and maybe to practice some of those hacks. But in order to make secure software, you don't really need to hack. The closest that you really need is to be able to test for certain security issues. And if you want to call that hacking, that is fine.
Yeah.
often you hear the advice that people should think like an attacker or think like a hacker, but also that requires some experience and some knowledge, so it's not a really useful advice there. They always say it's a bit like thinking like a chef and then putting someone in the kitchen and expect them to make a nice tasting meal. It doesn't work like that. So we need some training there, but in order to make secure software, being a really professional hacker is not necessary.
Okay, let's move on to the next one. And that's a question about OWASP SAM. And somebody wants to know, why did you choose OWASP SAM?
Why did I choose it?
Yeah.
It is a I actually like the structure. In the beginning, when the SAM project started, I was not very impressed, but recently version 2.0 has been released, and yeah, it really provides a helpful structure to look at all these practices. Now, of course, OWASP SAM only tells you about your process and your activities. It doesn't tell you how to actually execute those activities. So we need some guidance and some practice there. And but as a structure, I really find it helpful, and I use it for explaining the process, and also how to execute certain practices really fits well in this OWASP SAM structure. So that's why I choose it. Maybe there's some particular question there of why people think I should have chosen something else. I would like to hear about those. But
Clear. Can a security master or security champion work on a different team than the software development team?
Yeah, the challenge of a security champion, ideally you want to make them part of the team, but that is not always possible, because people that have this knowledge, the security knowledge, they are really difficult to get. So what you sometimes see is that a security expert is part of a software security group, and they assist the team. So they, for example, they have office hours where people can ask questions, but they also assist the development teams on demand. So you don't necessarily have to be part of the team. You can be part of another team as long as you work very closely with the teams.
Yeah, you're looking for the synergy.
Exactly.
Between the teams. And somebody's mentioning that you haven't talked about secure deployment, and he wants to know how this is handled in a company. Is there something like secure deployment?
Oh, definitely.
Possibility of the team to manage that.
Yeah. In the time I had to select certain practices, but secure deployment is definitely part of the OWASP SAM structure, and they give some good advice there. So what is important here, what can go wrong during deployment, is that people make mistakes. They forget to configure certain things. So we can learn a lot from the DevOps transitions here. You want to automate your deployments as much as possible and make sure to build security in there, and then improve on that. Of course, you need to have your systems secure, hardened, etc. You need to get your environment secure, etc. But once you have that, you can have automated deployments and make sure that no security mistakes are made during deployment. So that's the advice that, for example, OWASP SAM gives about secure deployment.
Should you also test the scripting and the tools that do the automatic deployments?
Definitely. You want to make sure that they're correct and secure. So yeah, your deployment tools are software as well. So you need to make sure that they do things securely, and also that potential attackers cannot abuse those tools.
Yeah. I have an interesting question from somebody who says, suppose we follow a mature security development process. Is there a way we can demonstrate the security level of this software? So how secure are you in the end? Is there a method like ASVS or is there something else? I think they would like to know.
Nice that you mentioned this, because as I said, OWASP-SAMM only talks about the process, and they provide a maturity scanning tool there, a maturity assessment tool. But this only talks about your process, and you can have your process like really mature and still make insecure software in theory. So you want to have something that actually measures your product security. And a couple of years ago, I made an attempt together with the company I was working for back then, and it's called the Framework Secure Software. And this was a document that told people how to make more secure software, but also show that they paid attention to security. So in other words, you could make the security in your product visible. And our goal was to make a sort of secure software certification based on that. But unfortunately, due to all sorts of political reasons, that didn't work out. But in theory, you can show it. And the way I usually do that is to use threat modeling as a basic practice there. So once you have your security requirements and your threat modeling, you write them all down in a list. And in this list of threats, I ask people to specify how they are going to mitigate those threats and how they are going to verify that the mitigation works. I call this a TMV list. And if you keep this TMV list during your process at any time, you can show people how well you thought about security. The status of your product security becomes immediately visible. And you can also see how much work you still have to do in order to get a certain level of security. Again, 100% security is impossible, so you need to get secure enough. But this list can put a limit on it. You can decide, I only do this list in security, and that is enough.
Okay.
And yeah, if you keep that, then you can show at any time that you actually are doing things to secure your application itself. And that is less about the process and more about the content.
Okay, let's move on to the next one. And there's a question about if this is the first step to a DevSecOps team, if an organization already works as a DevOps. Is that true? Is it the next step?
Well, yeah, yes and no, because if you read the literature on DevOps, you will see that building security in from the start is already mentioned there. So if you do DevOps correctly, between quotes, you should have done security by design already. So DevSecOps or SecDevOps is actually basically the same thing, but it puts more emphasis on security. The nice thing here is once you have a DevOps structure, security can easily fit in, because most of the techniques that you can use to offload things from operations more to development, you can do the same for security. You can offload lots of security activities to development and work in the same way with them. And also security activities that are in operations, you instead of having the security team test them and verify them, you can have the operations team do that. So security can really nicely integrate if you already have a DevOps setup. And here I would start by doing a value stream mapping to see how your flow of activities go, and then see where the bottlenecks are that relate to security, and then fix them by changing some of the processes there, changing some of the security practices, moving them more to the left, or doing them in a different way.
Okay, we have time for one more question, and we have still some more in the list. We will answer the questions that we haven't time for now later on, and post the answers on the website. And the last question we will answer is, if the company is big enough, is it suitable to have a department of security champions, some kind of department of excellence? So is that something you should consider if you have a big company with lots of development teams?
Yeah, definitely. And in fact, one of the earliest literature on secure software development, the books by Gary McGraw about building security in, actually suggest that. They suggest to start with a software security group, a specific department that can that tackles software security. Later, yeah, not every company can afford this, so the form of security champions was then invented, where you embed the security champions in your team. But perhaps it can scale more to have a software security group in a big organization. And what they do is, yeah, they assist the teams. They have office hours where people can ask questions. They help them with threat modeling, with getting security requirements, helping with security testing, provide secure coding advice, etc. You need to find a way that scales best. And what you can also do is have a sort of hierarchical structure of experts, where you have a top expert that delegates a lot of things to other experts that do that, and have the teams, and that way you can, yeah, quickly scale to many groups. So one expert is assisting the team, but their level of expertise is limited, so they can only help with certain things. If things get too difficult, they ask their expert for help. If they can answer it, they can ask their experts for help. And yeah, this is a way to make it scalable, because unfortunately this knowledge is still really difficult to get into your organization.
Yes, that's so true. And I think we're still not very mature in secure development, and there's lots of work to do. And I think everybody is very happy with all the knowledge you have shared today with us. It was very interesting, and what I said before, even I learned a lot today. We have no more time for next questions. So what I said before, we will post the answers somewhere on our website or on our social media channels. I want to thank everybody for attending today and listening in for almost an hour. And keep an eye on the Secura website and our social media for other webinars and training courses that we offer. There could be some quite interesting between them in these times that we all work from home. And perhaps you have the time to listen in to some other webinar from us. Thank you, everybody. Thank you, Tim. And
yeah, I also like to thank everybody for their attention and wish them good luck in implementing your secure development process.
Yes, thank you, Tim. Everybody, thank you for your time. Thank you for attending, and stay safe.